Hi guys, my name is Rahul. I welcome you back to the third chapter. So I hope that you guys have watched the first and the second chapter as it is the continuation of first and second. So without wasting much of a time, let's start. In this class, actually we were supposed to start solving our data set for the project description what I have given in the chapter 2, but I thought before going to the Jupyter notebook, let's see what is exploratory data analysis, EDA. So EDA becomes very important for all those who are aspiring to be a data analyst. So exploratory data analysis, EDA, involves summarizing the main characteristics of a data set, often using visual methods to uncover patterns and spot anomalies. Now basically visual methods. Now what are the visual methods? By visualizing, by making it more appealing through graphs. Alright, so that's how insights are taken. Now that is what called exploratory data analysis. Introduction to EDA. Now EDA involves process of examining and visualizing data sets to understand their structures, patterns, and the underlying relationship between variables. Right, it typically includes a lot of things which we will be studying in further slides. Steps in EDA. First, and the first most is data load and gather data from different sources, data exploration, data visualization, right? So loading data using pandas. Now CSV. Now what do you mean by CSV? Now by now I hope that you guys know what is CSV. CSV is comma separated values, a widely used plain text format from tabular data where each line represents a row and columns are separated by commas. Now how do you read it? Using pandas. Remember, we use pandas. So first we have to import pandas, right? So we import pandas. Pandas is a library, right? So I don't want to write it pandas again and again, so I would want to give it an alias called pd. So I would now this is the function I'll call pd.read_csv, and in brackets, in quotes, I would give the location of the CSV file where it is in my local, or if it is in my GitHub or Kaggle or somewhere else, right? And then I would want to store it in a variable called data, right? So this is the function, right? This is the syntax for it. Now Excel. Now how do you read it from Excel? Similarly, like CSV, I would do it from Excel. Now this is the typical similar to the CSV. This is the Excel syntax. Data exploration using pandas. Now these are the different methods through which we can explore the data, right? So before going for exploratory data analysis, I want to explore my data, how it is. Now data dimensions, how am I going to get it? That is data.shape. Now df.shape. Now so df is the data frame, right, in which I have stored. So in previous slides you can see that I have stored it in data, but in here I have given example for df, right? So df.shape will give me number of rows and columns. df.head will give me first 5 rows. df.tail will give me last 5 rows, right? df.info will give me data types and non-null counts. All right, so these all things which we will be seeing in the next video, where I will solve one data set. Okay, df.type data types, df.dtypes. df.describe, so it generates summary statistics for numerical column including count, mean, and quartiles. Now df.describe is one of the important aspect, and you should be in a level through which you should get to know just by watching what is df.describe. You should get to know the idea about how many null values are there, what is minimum, maximum, what is mean, if the column or if the variable is skewed or not, if it is following normal distribution or not, how much is the mean, how much can be the standard deviation, how spread the data is. Now these all things can be, the first glance of df.describe should give you these all things. All right, so don't worry, when we'll solve the data set, at that time I'll tell you how to glance from df.data type. All right, so this info will also give you how many null values are there and what is the data type of it, and df.tail and df.head is just to see how the data is going around, like what all are the values. All right, so definitely you won't be able to get to know the entire data set, since there will be thousands or lakhs of data, right? So you just have to have an idea or first glance of the data, how it is, right? So that's why df.head, df.info, and this df.info will also give you the data type of it. Now this is the typical syntax, right? So import pandas from pd. df I have load pd.read. like we read the CSV file, and then I have printed my df.shape. As you can see, df.shape is the dimension which I am printing, number of rows into columns, rows and columns it is going to give me. df.head will give me first 5 rows, df.tail will give me last 5 rows, df.info will give me summary of the data frame, df.dtype will give me the data type of each column or variable, and this df.describe will give me descriptive statistics for numerical columns. All right. Now data summarization. Now data summarization involves summarizing data into meaningful statistics or metrics that captures the essence of the data in a condensed format, providing clear and concise information to aid a decision-making process. Don't worry, we'll see data summarization. Common methods of data summarization are descriptive statistics, that is measures of central tendency. Now, what do you mean by measures of central tendency? Now, this comes under statistics. All those who belongs to mathematics or statistics background, they must be knowing about measures of central tendency and measures of dispersion. As the name suggests, measures of central tendency means mean, median, and mode, right? So mean, what do you mean by mean? I would not go in detail, but what do you mean by mean is average, right? So mean is the average, median is the middlemost value after sorting. All right. Mode is the most frequently occurred value. Remember this thing, there can be more than one mode. All right, there can be more than one mode, and for each numerical column we have two options. If for each numerical column, if there are null values, we have two methods to replace it, either by mean or median, depending on the circumstances. So for example, if my column which has null values is not following normal distribution, or if it is not following, or if it is skewed, or if there are outliers, then definitely I would not go by the mean, I would definitely go by median, because we know that mean is highly affected by outliers. If there is outlier, then mean is highly going to be tending towards the outliers. So that's why at that situation we'll definitely go for median. But if the variable is following normal distribution, then definitely I can go with mean. And whereas if it is a categorical data, by now I think you must be knowing about what do you mean by categorical data. Now in the categorical data, say for example sex column, at that time if I have null values, say male female, and there are some null values, at that time I'll definitely have to go with the mode, right? And remember this thing, very important, there can be more than one mode. Now what we are going to do in case of there is more than one mode, with what mode I am going to replace the null value? That is the first mode. Okay, first mode. That's why we mentioned when we are replacing the null values, that's why we mentioned square bracket 0, because the indexing in Python starts from 0. We will be seeing about it, don't worry. Now next is measures of dispersion. Measures of dispersion is how spread the data is, right? So in this we calculate the range, or we get the range, we find the variance, we definitely find the standard deviation. Standard deviation is nothing but the square root of variance, right? So this is how this gives me the measures of dispersion, like how spread the data is. Now how do we calculate it? We can get it by box plot, we can get it by hist plot, we can also get this measures of dispersion from df.describe method. All right, so we will all be seeing in practical once we'll start solving the data set. Now data aggregation. Now data aggregation, summarization by category, aggregating data based on specific categories or groups, such as computing the total sales per region or average scores per class. Now this majorly uses, like one of the most common method used for data aggregation is group by method. All right, again we will be seeing in detail in when I'll solve in the data set in the coming lectures in the next chapter. Data aggregation is a powerful tool for summarizing and analyzing the data. It allows us to generate insights, statistics, as we have seen. Grouping the data as using group by method in pandas is used to group data based on one or more than one column. All right, so say for example, if I want to use group by, for an example, how much sales is given by male versus how much sales is given by female. So I am grouping male, and then I'm calculating sales, and then I'm grouping female, and then I'm calculating sales. So with this I use the group by method. All right, it essentially divides the data into groups in which, like male and female, based on their unique values, right? So that is what I've said. So yeah, this is what it is. So if you want to group it, like this is just a syntax for grouping, right? If you, so say for example, if there is a column called sex, right? So you mentioned category in place of you mentioned sex in place of category, so it will give you count. So if you want to group it by and also want to find the sales, how much happened, so you will mention one more column name, that is sales, and then if you want to find sum of it or mean of it, whatever you want to find it, right? So that is what it is. Now applying aggregation functions. Once a group is created using, now these all things you can definitely go read it out. All right, so sum, mean, count, minimum, maximum. So all this you can also find it by df.describe, but that is for the entire data. But if you want to group it, if you want to group, right, so you can see what I've told you, like dot sum if you want to find the sum or mean or count. If you want to add one more column to it, if you want to like the example I've given, how much sales happened for male versus how much sales happened for female, you also mention one more column name here as sales, right? So you will get the whatever desired output you want. Now we come to the most important thing, that is data visualization. Now guys, all those who are going for data analyst position, data visualization becomes very, very, very important. You like open a notebook and start making notes out of it. Data visualization is a graphical representation of data to help us explore and understand the patterns, trends, and communicate insights hidden in the data. It uses visual elements such as charts and graphs to make complex data more understandable. Levels of data analysis in visualization: univariate analysis, in which only one column or one variable is involved, and for that we use histograms or box plot. Histograms for seeing how spread the data is, box plot to see what is the minimum value, what is the maximum value, how spread the data is, what is the first quartile, what is the second quartile, what is the third quartile, what is the median, and all, right? Bivariate analysis, where there is a relationship between two variables, right? So there is two columns, say for example, like the example which I have given, male female, and not male female, but this has to be in the numerical format, right? So for example, height and weight. So for 150 centimeter, how much can be the weight? Say suppose 50. So that is one. This is a relationship between two using scatter plot or correlation matrices, etc. Multivariate analysis, in which there is a multiple variable included. Say for example, heat map, pair plots, and example, right? So identifying patterns or trends. Look for the patterns or trends. This is what it is. Use appropriate plots. You can use appropriate plots for categorical numerical data, right? So which we'll be seeing in these types in coming slides. Now basic plot types. First is line plot. A line plot is used to visualize data points over a continuous interval. Remember, this word continuous interval is very, very, very important. See, you guys are going to be data scientists or data analysts, so using specific words for that specific definition becomes very important. By this, if you mention this in front of the interviewer, then you are giving out that you know things. Typically connected by lines, it is commonly used for time series data or data where the order of data points matter. Say for example, linear regression, in which we want to find the line, right? So that's why we use line plot. Matplotlib, how do you write this in text for Matplotlib? You just from Matplotlib I import pyplot as plt. So I would want to give it alias as plt. So plt is nothing but pyplot. All right, so plt.plot, and then you give x and then y. Similarly for Seaborn, what you would do, you would just write sns.lineplot, Seaborn as sns, so alias is sns.lineplot x and y. Now this is how typically it looks like for each date, how much stock price is going out, right? So this is what the typical line plot looks like. Next is scatter plot. Scatter plot is used to visualize the relationship between two numerical variables. Each data point is represented as a dot, with one variable on the x-axis and other on the y-axis. Matplotlib, that is plt.scatter x and y. For Seaborn, it is sns.scatterplot x and y. Now this is how scatter plot looks like. All right, so this is one dot dot dot. Remember, scatter plot in Power. I'm just going out of line over here, out of context over here. Power BI, scatter plot and bubble plot indicates the same thing but are not the same thing. Remember, in scatter plot what happens is the dimension of a single dots are same, but in bubble plot, the dimension also plays an important role. All right, so just wanted to segregate both the things. Next is bar plot, one of the most important, one of the major plot, one of the most widely used plot is bar plot. A bar plot, a bar chart, is used to display categorical data with rectangular bars. Each bar represent category, and height or length of the bar is proportional to the value it represents. Matplotlib plt.bar x. All right, for Seaborn SNS. So this is how it looks like. So apples, say for example number of units sold, so there are like approximately 120 apples which was sold. Bananas somewhat 90, oranges somewhat 80, grapes somewhat 70 or 60, right? So this is what it is. Next is histogram. Histogram is used to represent the distribution of a continuous or numerical data set. Remember, histogram is connected. There is a huge difference between histogram and bar plot, right? This is a typical interview question also, so make a note of it. In histogram, it is continuous for numerical data set. It divides the data into bins or intervals, all right, and display the frequency of data points in each bins. Now matplotlib, you can see plt.hist, and then Seaborn, it uses histplot as x and bins. Now this is what it is. Say for example test score, how many people who lied between 0 to 20. So there are like 5 6, 20 to 40 this much, or 20 to 60 this much, 50 to 60 this much, 60 to 70, 70 to 80. Now these are bins, right? These are connected buildings. Now the major difference between bar plot and histogram, there is a connected building in histogram, but in bar plot there is no connected buildings. In bar plot there is a x-axis becomes the discrete value, but in histogram the x-axis is continuous data. That's why it is continuous, right? And then this is the frequency of the students, right? So this is the major difference between them. Box plot or viscous plot. Now box plot is used to display the distribution of a data set, particularly its central tendency and spread. It shows the median, quartiles and any potential outliers. So this is, now box plot, you are definitely going to use it in most of the cases to visualize how many outliers are there, to visualize how spread the data is, right? So you have both the choices, either from matplotlib or a Seaborn. Now this is how the box plot looks like. See, now this part, remember the cursor where it is going. The red dot are the outliers. So you can see the minimum value is 60, approximately 60, 61, maximum value is 91, and then the major data lies between 70 to 80. And if major data lies between 70 to 80, for class A I'm telling you, for major data lies between 70 to 80, there has to be mean median mode over here itself. So this is the orange line indicates the median, alright. Now this line is Q1, Q2, and this is Q3. Alright, so this is what it is. Now Q2 is 50%, right? So Q1 is 25%, Q2 is 50%, and Q3 is 75%. And this is my minimum and this is my maximum value. So Q1, Q2, Q3 is the major data where it lies, right? And also this Q2 is 50, since Q2 is 50% and median is also the middlemost value. So that's why Q2 and median becomes the same in the box plot. Alright, so this is what it is. The next is pie chart. A pie chart is used to display the composition of a whole in terms of parts. It divides the whole into slices like a pie to represent the relative sizes of different categories. Of course, the definition is too big. This is what it is. Similarly, for Seaborn, you can look out for it. Okay, so this is how typically pie plots look like. Say for example, how much revenue has been generated by ad revenue, that is 6.7% of the total revenue. 20% is being generated from subscription fee, 26.7% from services contracts, and product sales, 46.7% of the revenue is being generated. So this is how pie plot gives you. Next plot is heat map. Heat map is a graphical representation of a data where value in a matrix are represented in colors. Now heat map is majorly used for correlation, right? So sns.heatmap, and then you give the data. Now this is how the heat map is. Now these are my columns, say for 0, 1, 2 and 0, 1, 2. So suppose any name, like it is being given as the column name as 0, 1, 2 and 0, 1, 2. So the correlation between, say for example, this is not giving you the correct insight, as the correlation between 0 with 0 has to be 1. This is not a very good representation of correlation, I would tell you. I would want you to go on to Google and search for heat maps. Then you will get to know. And one observation I want you to make is, look for the diagonal values. The diagonal values will always be 1. Now why it will be 1 is because, now what do you mean by